In our network design, we fill in the network IDs and subnet masks. We also fill in all the IP addresses for the various interfaces and devices. In this video, we will be looking at how our devices actually work on these decimal numbers, but they do it in binary as zeros and ones. This is PC3. We have the IPv4 parameters down here, the IP address, the broadcast address, the subnet mask, the default route or default gateway. So here we will be looking at what is behind these numbers. In order to do that, we have to look at the decimal number system, as these numbers are decimal numbers. Let us bring up a spreadsheet and relearn how to count items in decimal. When we have 0 items, we mark that with this symbol, 0. When we have counted 1 item, we use this symbol here for that, the 1. The symbol for 2 is this one. When we have 3 items, we mark that by this symbol. This symbol for 8, this symbol for 9. And now we do not have any more symbols. We are out of symbols now. We only have 10 symbols in the decimal, in the 10 system. We have counted 9. The next count is 10 items. We mark that on the position to the left here with that we have counted 1 time 10 items and 0 time 1 item. Counting on 1 time 10 items and 1 time 1 item, that is 11. 1 time 10 items and 2 times 1 item, that is 12. And it goes on and on. When we get up to 1 times 10 items and 9 times 1 item, we have the problem again that we are out of symbol here where we count the ones. What we do is that we now indicate that we have counted 2 times 10 and 0 times 1. That is what we call 20. 2 times 10 and 1 times 1, 21. We are out of symbols on both positions. We now mark that we have counted 1 time to 100, 0 times to 10 and 0 times to 1. We can actually mark up here that at this position, in this column, we are counting the ones. In this column and this position, decimal position, we're counting tens, and here we're counting hundreds. And you might have guessed that over here we are counting the thousands. So let us start counting in binary. When we have counted 0 items, we mark that with this symbol, the 0. When we have counted 1 item, we mark that with this symbol, the 1. In the binary system, we only have these 2 symbols, the 0 and the 1. So now we are actually out of symbols. What we did over here in the decimal number system when we ran out of symbols was that we moved 1 position to the left and we marked there that we had counted 1 time to 10. But in this case here in the binary system, it is 1 time to 2 and 0 times to 1. 1 0 in binary is 2 in decimal. Let us count on 1 time to 2, 1 time to 1, and that is 3. And we are out of symbols again. We mark that we have counted 1 time to 4, 0 times to 2, and 0 times to 1. 1 0 0 in binary is 4 in decimal. In binary, the positional values are thus 1, 2, 4, 8, 16, and so on. As IPv4 addresses are always 8-bit quantities, we will write these numbers out in binary as 8 bits, even though the decimal number is not actually needing 8 bits. For decimal 99, we fill in a leading 0 to fill in all 8 bits. And also for 99, we fill in a leading 0 to fill in all 8 bits. The number 255 is in IPv4 of special interest to us, as it is often used in the subnet mask and also often used in the broadcast address. Let us now turn to see how binary IP addresses are working. Let us bring up a spreadsheet, our network design, and a Linux machine. The PC3 in our diagram, and the IPv4 parameters. Let us break the IP address down into binary. I will encourage you to please try and do the conversion from decimal to binary manually. 192 breaks into 128 plus 64. That is why we have 2 ones in the 128 and the 64 position. When PC3 receives an IP packet with this binary pattern as the destination IP address, then PC3 knows that this IP packet, that is for me. On our Linux machine, we have also configured a subnet mask. Let us see now what that is used for in binary. And converting, calculating into binary. A subnet mask has to be a consecutive string of ones from left to right, in this case 24 ones in an unbroken string. The subnet mask is used by our device, in this case our Linux machine, to learn what IP subnet it is on. It calculates that from the subnet mask and its IP address by logically ANDing bit by bit. 1 and 1 yields 1. 0 and 1 yields 0, and so on. And writing out in decimal the network ID for networking devices on LAN 3, in this case the network ID for PC3. A subnet mask with 24 binary ones is indicated as a /24 network. PC3 uses its calculated network ID to figure out if an IP address is on the same network as it is on itself. Here we are pinging 13.2. PC3 now compares its network ID with the net ID portion in the ping IP address. They have to be identical. When PC3 sees the indicated binary difference, it is configured to send this IP packet to its default gateway, which is a router which will route the IP packet on. The subnet mask is also used by PC3 to calculate the broadcast address for the network it is on. PC3 looks at the portion of the network mask where it says 0, and where it says 0 it has to put all ones, and that is known as the broadcast address now. Let us also write that in decimal. Let us take a look at IPv4 addresses for SRX2, which is on LAN 5. Let us write up router 2's IP address in decimal and in binary on LAN 5. In our network diagram or network design, the subnet mask is indicated to be 30 bits long, a consecutive stream of ones, 30 ones in one long stream. The router will deduct the network ID from the network mask and from the IP address. The router will also use the subnet mask to figure out what the broadcast address is. Only 2 bits are left for the broadcast address, so those 2 ones is what gives us the broadcast address. 3 in decimal as indicated here. In the next video we will see further that the subnet mask also dictates how many devices we can have on one network.